Hello, my name is Anna, and I will be presenting a smoke and fire detector for software engineering 452W. In this project, I built a gas and smoke alarm system using an MQ2 gas and smoke sensor and a piezo buzzer. Every time the sensor detects gas or smoke in the atmosphere above a certain threshold, the buzzer sounds. For the hardware, I used Raspberry Pi 4 as it was required in our project. I also used a breadboard, MQ2 gas and smoke sensor. This is the one. And MCP 3008 analog converter, a piezo buzzer, an LED that turns on as soon as the sound turns on, a resistor to connect the LED, a push button, and jumper wires. For the software, I used Python, and those are the libraries that I used to build the server. The project is actually running on my Raspberry Pi, and I can turn it on or turn it off through a web page. So I set up a HTTP server with the base HTTP request handler and HTTPS server libraries. For the input and output, I used RPI.GPIO and GPIO 0. And for the threading, I used threading libraries. The basic input output layout of this project as I connected the button to GPIO 2, the LED to number 17, buzzer to 27, and MCP 3008 to number 1. The GPIO pins on the Raspberry Pi are used to connect and control the hardware, as I already mentioned. For example, we use one pin to control an LED, another one the buzzer, and third one for the button. These pins help the Raspberry Pi communicate with the real world by sending signals to turn components on or off, and also receiving input from sensors. The HTTP server serves as a helper in this project. It lets users control the system through a web page. It also runs on the Raspberry Pi, as already mentioned, and listens for the requests from the user. Those requests are turning the gas sensor on or off or checking the sensor status. The server sends back an update web page with information like whether the sensor is active or not, the current gas level, and any alarms. Okay, this is an example of the main class that is actually using threads and running the server. So the threading is used in this project to let the server and the main program run at the same time. While the server handles web requests, the main program continues to monitor the button and gas sensors without any delay. The thread makes sure the system doesn't freeze or stop responding when the server is busy. So overall, this keeps the whole system responsive and ensures it can react quickly to dangerous gas levels or user input. Okay, and this is actually how the front end looks like. For the front end, I used JavaScript and CSS. And I will proceed to a quick demonstration. And here I set up my laptop to enter to my Raspberry Pi through SSH, and I'm using VS Code for that. So I will run this project. Right away you can see that the web page that was not working started working, and here I'm having a thread running the values and also one for the web page. I can turn on the fire alarm from pushing the button or using the web page button on. Okay. So right now the value is 0.0. I just wanted to mention that I set up the threshold very small to 0.0002. As you can see, the gas level exceed threshold. It's 0.05, and right away the piezo buzzer started beeping. The web page does not reflect the latest values, and we need to actually use the refresh button. I wanted to implement WebSockets, but I had some technical difficulties with that, so I kept it simple for now. So as you can see, the values went to normal again and stopped beeping. And again, it's 0.03, and alarm gas level exceed the threshold. Usually the threshold is set up to 0.1, but just for the sake of the presentation, I set up the threshold lower so I don't have to use actual lighter and a candle. But I think I will actually demonstrate how it works in real life. So as a final demonstration, I wanted to go over how the gas sensor works in real life. I will restart my server. Again, I SSH to my Raspberry Pi from my computer, running the project. Okay, restart, refresh the web page. Right now, and I also wanted to mention that I increased the threshold to 0.03, and it is digital right now. I will press on, and right away it starts beeping because the threshold is 0.03 as I mentioned, but the value is 0.06. Okay, I disarmed again the alarm system, the fire alarm system. I also wanted to quickly show how it will read the data. Right now it decreased to 0.001, and how it will start reading after I lit a candle. Okay. I will arm the smoke alarm again, refresh. Okay. Let's see, maybe I should. Not enough smoke, I guess. Okay, maybe I'll use 2 candles. Okay, and as you can see, the gas level exceeded. It went to 0.03, 0.04, and it started beeping. Again, I can't turn it off from my web page, so you don't have to hear this annoying sound. Okay, and that was my real life demonstration. Thank you. Goodbye.